Chapter 3, Part 4, Interfaces. This is the third definition of interfaces that you'll see when you come in contact with Java programming. And an interface is a collection of related methods whose headers are provided without implementations. What that basically means is it's a collection of abstract methods. So all the methods in the interface are public and abstract. There's no need to explicitly include those keywords because they are by default and necessity public and abstract. You cannot instantiate objects of interfaces. Any class that implements an interface must provide implementations for all of the methods in the interface. Somebody asked me, what's the point of interfaces? These are not classes, but I think it's my opinion based on what I know about Java and its development, that when the nice folks at Sun Microsystems set out to design Java, that they wanted to make it an improvement over what you could get with C++. And one of the disadvantages of C++, one of the things people found confusing, was this concept of multiple inheritance, that a class could have more than one superclass. And so they said, we're going to get rid of multiple inheritance, we're going to make it easier so you don't have to worry about who the superclasses are, and they made this thing called interfaces, which is a way around multiple inheritance. I don't know if it's any easier or not. It's just different. So if you ever code in C++, there are no interfaces, but there is a concept of multiple inheritance. So how we define an interface is we say public interface. Notice we've replaced the word class with the word interface. And then we provide a name. The rules for naming interfaces are the same as the rules for naming classes. We start with an uppercase letter, no keywords, no special characters, no spaces. And then our interface looks a lot like a class, except that it's just got method headers in it. In this case, a flying object has a method fly, which returns a void, and it has a predicate method isFlying, which returns a Boolean. Remember, both of these are public and abstract by default, and necessity, so we don't put the words public and abstract. To implement or use an interface, you have to use the keyword implements. So we can say that our public class bird implements flying object. That means inside our class bird, we have to provide a method for the fly and the isFlying method. So fly would return a void and accept no parameters, and the isFlying would return a Boolean and accept no parameters. Bird can add anything else that it wants, but it must implement the abstract methods from flying object. We can also see an example with mosquito here. Public class mosquito extends insect, implements flying object. Insects, I guess, are not necessarily flying, and so if we want to make an insect that flies, we have to add something special, like a fly method and an isFlying method. So public class mosquito would both have insect as its superclass, and it would need to provide an implementation for both of the abstract methods, both of the methods inside the interface flying object. So the extends clause, if you have an extends clause, let's back up just one second. Mosquito extends insect, implements flying object. The extends comes first. So notice in bird does not have a superclass, it just implements a flying object. But in the case of mosquito, it extends insect and implements flying object. So the extends come first and then the implements. You can have just one superclass, but you can have many interfaces. So you could implement flying object, comma, I don't know, creepy, 6 legs, whatever other interfaces you might have for your mosquito. The comparable interface is probably one of the most widely used in Java, and I think it's very important. It was left off the 2015 AP exam, and I have no reason to believe that it has gone. I have no information leading me to believe that it has snuck its way back into the 2016 exam. But sometimes things that are declared specifically outside the AP subset are nevertheless used in one way or another. And I think that because the compare to method is used inside the string class, that it's worthwhile for us to spend a little bit of time with the comparable interface. So the comparable interface provides the compare to method. And let's take a look quickly at the compare to method. It returns an int, and it accepts as a parameter an object. In this case, we're calling it obj, which is of type object. It returns a negative number, a 0, or a positive integer based on whether the implicit object is less than, equal to, or greater than the parameter. So if our current object, the one that's calling the method, the compare to method, is less than the object that we're passing in as a parameter, we're going to return a -1. If they're the same, we're going to return a 0. And if the implicit object, the one that owns the compare to method, is greater than the object we're passing in, then we return a 1 or a positive integer. And you might be curious, what is greater than? Well, it all depends. It depends on what your instance fields are and what exactly you want to compare. You know that when you compare reference types, you can't just use your relational operators like less than or equal to, greater than, and so forth. Because what is a reference type? A reference type is an address. So if you want to be able to compare reference types, you have to provide a method that's going to do that comparison for you. And if you want to be able to compare objects, I think it's useful to have that class implement the comparable interface so that you will be following this compare to model, which is pretty standard across Java. So let's compare interfaces and abstract classes. I'll be honest with you, I have no idea why I included this picture of Battleship. I think Battleship is an awful lot of fun to code because it uses a two-dimensional array, and I think it's a lot of fun. I really like Battleship, but I have no idea why I put it on this particular slide. So whatever. You use an abstract class when the object is an application specific, but incomplete without its subclasses. So if you want to make sure that all of the subclasses, or at least a good number of the subclasses, I guess it would be all of the subclasses. It was just stupid of me to say some of them. All of the subclasses implement a certain model, certain methods, then you would use an abstract class for your superclass. Consider using an interface when its methods are suitable for your program, such as the comparable interface. I think that's a really useful one. But could be equally applicable to a variety of programs. So the comparable interface is, for an example, you can compare many disparate type of objects. You can compare dominoes. You can compare bank accounts. You can compare any number of different types of objects, but it depends on what the instance fields are, how you determine which one is greater than or less than another. Those are really good examples for implementing the comparable interface. An interface cannot provide implementations for any of its methods, whereas an abstract class can. An abstract class can contain methods that are not abstract, whereas an interface cannot. An interface cannot contain instance variables, whereas an abstract class can. An interface and an abstract class can both contain constants, and it is not possible to create an instance of an interface or an instance of an abstract class. So in summary, for Chapter 3, you should be able to explain the difference between the following concepts: an abstract class and an interface, an overloaded method and an overridden method, and dynamic binding, also called late binding, and static binding, which is early binding. All of these concepts relate to polymorphism, which I think is the crux of Chapter 3. Please feel free to come in and work with me at any time. I'm here before school. I'm at school after school, and I'm also available via email. I respond to email pretty quickly most of the time, and I look forward to working on code with you. Have a great day.